Hello students, today we will talk about our next topic, that is mass moment of inertia of rod. And this time we will find the mass moment of inertia of rod about one axis, let us say y-axis, and that axis is placed at the extreme left end of the rod. Fine. So that is why it is written about one end along y-axis. So we are given one rod, circular rod, and its length is mentioned as L units, and three axes are shown. At this end, two axes are made, that is y-axis, z-axis, y-axis, and x-axis. So, in order to find the mass moment of inertia of this particular rod about, let us say, this particular axis, that is y-axis, let us see what is the procedure. So what we have done, we have shown the same rod with dashed lines, fine, in order to make things more clear, and we have shown all the three axes, y-axis, z-axis, and x-axis, and we have considered one elementary we can say small element of that particular rod, and let us say length of that element is dx, and it is placed at x units from y-axis. Okay, so in this case there is one very important part to understand, that the whole of the mass of the rod is distributed along its length. So in this case, when we have to find rho, that will be called as mass per unit length, not volume, because most of the mass is concentrated along its length, is distributed along its length. So rho in this case will be mass per unit length, that is density, which will be equal to mass per unit length, m by L. So first step is we will find mass of the small element. How you will find the mass of small element? We will multiply the rho, that is mass per unit length, by its length, that is dx. So mass per unit length is m by L multiplied by its length, small element, that is dx. So this will become the mass of that particular small element. Further, we will find mass moment of inertia of small element. So we will find moment of inertia, mass moment of inertia of this particular small element about this particular y-axis. So that will be denoted by di. So that will be equal to what? That will be equal to mass of this particular element multiplied by its distance from that particular axis, which is x, square of that distance. Fine. So that is why it is written di is equal to dm dot x square. So further, if we want to find the mass moment of inertia of the whole rod, then what do you have to do? You have to integrate this particular term between limits 0 to complete length L. 0, because this is the axis about which we want to find mass moment of inertia, from 0 to length L. So we will write mass moment of inertia of this whole rod about this particular axis will be Iy will be equal to integration of this particular term from 0 to L di. So further, put the value of di, that is dm dot x square, put the value of dm, what is that value? M by L into dx, m by L into dx dot x square. So m by L over here is constant, take outside, so take the integration of x square dx from 0 to L. So you will get x cube by 3, put the value of L, so you will get m L square by 3. So this is the mass moment of inertia of the rod about y-axis when it is placed at one end of the rod. I hope this particular derivation is clear to you. Thank you very much.